In this video, we're going to start a new section, section 18.0. And the 18.0 series has to deal with list of structures, right? Anywho, I have the problem opened up in Racket, so let's just go over it. So notice how the data design steps, some of them are already done, except for step 4, which we're going to do shortly. So I recommend you guys pause the video and get yourself acquainted with some of these steps that are already done, right, for the data definitions here. All right, so for the sake of time, I'm just going to glance over them, right? And skip right to problem A. So problem A, finish the template for list of employee. So here it is right here. We have the signature list of employee temp, right? EMPL, it's short for employee. Dash temp is short for template. Consumes a list of employee and produces, we don't know yet, because this is just a template and it's just laying out a good foundation and scaffolding, all right? So pause the video and try to work through this on your own. The template step, write the template for list of employee. I'm going to go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So I'm going to say define list EMPL temp, right? So list of employees temp. So it consumes a list of employees. So I'm going to call the input parameter EMPL-ls. You can name it whatever you want. And since a list of employee consumes a list of employee, that is either one of an empty, right? So it can either be empty, so we have to check if the employee list is empty, right? If it is, do something. Otherwise, right, we want to do an operation taking apart the list, right? So EMPL-ls, and then we want to call the recursion on the rest of the list. All right. So there's something, this is going to be a little different, right? So notice how the list of employees, this is a non-base type, right? It's not a string, it's not a number, it's not a boolean, it's an employee, right? This is not a data type that comes with Racket. It's something that we defined ourselves with define struct, right? And the key insight here, right? The key difference between the templates that consume a list of, booleans, list of strings, list of numbers, etc., is that when we do first of EMPL-ls, we're going to need to wrap this in a helper function, right? We're going to wrap this to the call to the template of employee-temp, right? So employee-temp, right? So that's the key insight, right? When we have a non-standard base type, right? A list of a non-standard base type, right? Such as employee used by define structs, right? We're going to need to wrap the first of ls here into a helper function. And you're going to see why that's going to be useful in problems B and C, right? It's because we're going to need to take apart the structure most of the time, most likely. And yeah. Anywho, that is it for problem A. Now let's move on to problem B. So I'm going to scroll down here. Problem B, design a function raise-wages that consumes a list of employee and a number and increases everyone's wages by that number, right? So they give us the signature here, right? So it consumes a list of employee, right? And a number, so it's the 2-argument function, and increases everyone's wage by that number. So it still produces a list of employee. And here's the purpose, increases the wages of all the given employees by the given raise, right? So signature, purpose, you can stub this out. Let's just do that really quickly. Define raise wages, so consumes an employee list, and then a number, so we'll call it n, and then it produces a list of employees, right? So we'll just use empty for now, all right? So pause the video and try to work through the other steps of the design recipe for functions, right? Signature, purpose, stub, examples, and etc. All right? Pause the video and try to work through it on your own. I'm going to go with spoilers in 3, 2, and 1. All right, I'm assuming that needs a good swing in it, so now let's go over it together. So let's write some examples for this, actually. So check expect raise wages. So we'll say empty, and then the raise is like $4, right? So this should still produce an empty list because there are no employees in this list, right? Increases the wages of all given employees by the given raise, right? This is the given raise. The given employees, there is none, so just reduce the empty list. Otherwise, right, we have another case here, raise wages. Let's do list, and then let's do our employee. So I'm going to copy one of these down here. In fact, I'm going to copy this entire data definition down here because we're going to need to see it side by side. It's going to be easier rather than me scrolling up and down all the time, right? So we're going to say list, and we're going to say Ava. In fact, there's another list here, right? These. So I'm going to copy those down too. All right, these are the lists. All right, so Ava, so here's Ava, right? So if we raise her by $4, right, over here, right? Then we're going to have to produce a list, right, where the employee's wage, right, so this is the wage field. Ava Ryan is $32 per hour and is a manager, right? She earns $32 per hour, right? So I'm just going to copy that. We're going to need to produce an employee where Ava's wage is increased by 4 here, right? So it's going to be 32 plus 4. That's 36, right? All right, so let's do another example here, right? So I'm going to do raise wages. Do a too long test. List, let's say Bob and Jess, right? So these two, right? So this is their names, the wages, and then their role, right? So junior, intern, manager, senior, etc., right? So we're going to raise their wages by, let's say, $2, right? So this function should produce a list where we have Bob here, right? And Jess is also this, right? Produce a list where their wages are raised by $2, right? So you could do this 21 plus 2 is 23, right? But I'm just going to wrap this around a plus 2. That is also the same example, right? But it's sort of easier to see what we're doing, and it helps us in writing the function. Anywho, that's pretty much a good amount of tests, right? We have the empty list, a 1-element list, and a 2-element list, and usually that's enough, right? So that is the example step done, right? Now let's just run our stub against our examples here, and we get mismatches. Empty differs from that, empty differs from that. That is fine. Just mismatches, right? So I'm going to delete the template. You guys can keep it around if you want, right? And I'm going to grab something that consumes a list of employees. Going to look around for some scaffolding here. And likewise, we just did scaffolding for problem A, so we're going to use it like so. And we're going to rename this raise wages. Consumes an employee list. It consumes 2 arguments, right? Raise wages. So it consumes an n. We'll call this the raise instead of n. All right. So really pause the video. Hopefully this should be all the mental scaffolding needed to solve the problem for raise wages. I'm going to go with spoilers in 3, 2, and 1. All right. I'm going to assume that you guys took a good swing at it. So now let's go over it together. So what do we do when the list is empty? Well, here is the example that tells us what we need to do. When it's empty, just produce empty. All right. So that is that first case done. Now comes the harder cases, right? So what happens when there is a list of employee, right? What happens when we're given a list of employees, right? So this one has the list Ava, right? So here's the original Ava. Her original wage is 32, and we produce a list of employees where her wage is updated to 36, right? Because 32 plus 4 is going to be 36, right? All right. So what we need to do is, right, so we have to produce a list of employees, and the only way you can produce another list is with cons, right? So we know what this ... is going to be. It's going to be con just by this deductive reasoning of looking at the output type and seeing what we got to do to produce that. All right, now what we got to do is we got to use this employee dash temp, right? We want to raise the wage of her, right? Raise wages, right? But this already refers to this function, so let's call it update wage instead, right? This function doesn't exist yet, right? We're going to have to write it. So we want to update her wage, right? This is going to be the employee Ava by 4, right? So this is going to be a 2-argument function that we're going to write, all right? So let's do that now, actually. So update dash wage consumes an employee, and then also a number, and then produces the employee, all right? And then the signature is going to be produce the employee with the wage field increased by the given raise. All right, so this is going to be the raise, all right? So signature, purpose, stub. So let's stub this out. Update wage, I mean. MPL seems like a good shorthand for this parameter name. And this is going to be the raise also. All right, this produces an employee. So this has to be a make employee. All right, so it takes in some name, some number, right? So we're just writing a dummy value, so manager, right, to run against your test, right? So there's some tests here. We only need really 1 test, right? And I recommend you pause the video and try to work through this on your own as I'm typing it through, right? So spoilers in 3, 2, and 1. So we're going to call update wage, right? So what happens if we call update wage on Ava, which, right, we gotta turn her, right, Ava, right, so she's over here. In fact, I'm just gonna inline this variable so I don't have to scroll up and down all the time so you guys can see the update here. Right, so this call with for should produce what? Well, it should produce an employee, right, because that's what the signature says. So make employee, where her name is the same, all the fields are the same, except for her wage, right? It's increased by 4, right? So her original wage is 32, we're gonna add 4 to it, all right? So hopefully this gives you an idea of how to implement the update wage function. So I'm just gonna run this test against the example here, right? But it might actually, we haven't finished this function yet. So in a way it's not, it might not pan out well actually. Yeah. Well, this function is failing, but you know, we gotta ignore that and just focus on this, right? So yeah, it's gonna say this is not working out, the raise wages. It's fine. We'll just ignore it. We're just focusing on the update wages. Update wages down here. Yeah, this one. All right. So maybe I was pointing out that all along, but yeah. Since we're not writing this, we're not finished writing this function, I would recommend you comment it out if it's like failing these tests. You can just ignore that for now because we gotta focus on this first, right? So it produces just a mismatch, right? Of this employee doesn't match with this employee, that's fine. So that's the stub done. I'm gonna comment out the stub this time. And, all right, we're gonna have to finish this function. So there's a template that consumes an employee, right? This is scaffolding that's done above, right? The employee template here, right? It's an employee template. So we can use that as a starting baseline for update wages. I'm gonna rename this update wage. Consumes an employee and also the raise itself, right? The number. All right. So now really pause the video. Hopefully this should be all the mental scaffolding needed for update wage. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you took a good swing in it. So now let's go over it together. So update wage, right? We know we have to produce an employee here. And the only way to do that is with make-employee. All right, so that's done. So everything stays the same except for the wage, right? Her name stays the same, her role stays the same, but the wage is increased by whatever this raise is, right? In this case, it's 4 over here, right? So we have to add the raise, right? The given wage that's inputted into this function. And that should pass the test here, right? So over here, it might not be, see, raise wages. So that's this function. 2 of the 4 tests. All right, so 2 of them did pass. So we're just gonna say it passed, right? And when we finish writing this function, then everything's gonna work out, right? So now we're back on our raise wages function, right? So update wage, right, is this, right? So we're done with the helper function here. And all we have to do is assume that raise wages will work for the rest of the list, right? Because it works for the 1 element list here, right? List Ava, increasing her wage by 4. But what if we have 2 people, right? 2 employees, 3 employees, etc., right? It's going to raise them by the appropriate amount every time. And we just assume that the recursion follows the purpose statement here. All right. Likewise, we're getting an error here actually because raise wages accepts 2 arguments but only found 1, right? We actually have to pass in the raise over here, right? Raise over here. And I see a mistake I've done here. So update wage 4, right? I was so focused on this example, right, that it, adds 4 to 36. But this 4, right, it's a 4 here in this example, but in this example, right, it's 2, right? So the wage, the increased raising of the wages, it can be 2 for whatever gets inputted this function. So this should actually be raise, all right? So that was a bug. And likewise, all 4 tests pass. And that is that problem done. So we're going to move on to problem C. So problem C says design a function filter-role, which consumes a list of employee and a role and produces only the set of employees with the given role. And they did the signature for us already. So pause the video and try to work through problem C on your own. I'm going to spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing in it. So now let's go over it together. So signature, let's write the purpose here, right? Produces only the set of employees with the given role. Okay, so signature purpose, let's stub this out. So define filter role, consumes a list of employees, so MPLS, and then the role. So we'll call it RL, right? It could be, we can just write the full name, why not? And then produces a list of employees. So we can just do empty for now. Now let's write some tests. All right, so check, expect. All right, filter role. All right, so we have to give it a list of employees, right? So we'll do list, and I'm just going to write down, let's say list. Well, there already is some predefined list here that we can use actually. So everyone, right? This everyone list contains Ava, Jack, Anna, and Bob, right? So Ava, Jack, Anna, and Bob. So 4 people, and Jess too, right? I missed that, right? So I'm just going to use that actually. So everyone, and you're going to have to keep scrolling up for that. We're going to go over that, scrolling up for the definition here, right? But that's fine. In fact, you know what? I don't want to keep scrolling up and down. I'm just going to copy and paste this and put it in a comment because, you know, we can't define it twice. So just going to stick that here actually. All right, so that we can see it. All right, so here's everyone. All right, so it takes in a list of employees. So that's the list of employees here, right? A list of employees, and consumes also a role, right? So let's do something like there's managers. Let's do manager, right? So manager, right? So there are 2 managers in the everyone list, right? Ava and Jack are managers, but everyone else is senior, junior, intern, right? So we should produce only the set of employees with a given role. In this case, the given role is manager, right? So we're going to do list, and then it's going to be, let's see, Ava and Jack, right? Because they're the only 2 that are managers. Ava and Jack, all right? Let's do another test here. I'm going to do one up here actually. Do it above because we should do the empty list too, right? So empty, if the employee list is empty and we pass an intern, it doesn't really matter because there are no employees in that list, right? Let's do a few more tests here. So check, expect, filter, role, everyone. Let's filter out the interns, right? Right, so Jess is the only intern in here, so intern. We should produce a 1 element list where Jess is the only one here, right? Because she's the only intern in this list of everyone, right? And you're welcome to do more tests here, but this should be enough. All right, so I'm going to run against the stub here. We should just get mismatches of empty and the list that we're supposed to produce. So we're good here. Going to come out the stub and look for something that consumes a list of employees that we can use as a scaffold. And likewise, we did that all the way back in problem A, right? So it's going to help us out here. The basic structure and getting out all the pieces and just the basic overall structure and stuff. All right, so we're gonna fill out this template. We're gonna have to rename this here, right? It consumes a list of employees. It also consumes a role, so there's 2 arguments there. All right, so now really pause the video. Hopefully this should be all the mental scaffolding needed to solve the problem for filter roles. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing in it. So now let's go over it together. So what do we do when the list is empty? Well, this example gives us that answer. We just produce an empty list and we're given an empty list, right? So that's that done. What happens when there are a list of employees in here, right? So in this case, it's everyone, right, in this list. Ava, Jack, Bob, Anna, and Jess, right? So we know that looking at the signature here, we have to produce a list of employee, right? So this has to be cons because that's how you produce a list, right? And likewise, we know that this list empl-temp has to be a recursive call to itself, which we'll assume will fulfill the purpose statement here, right? And here comes the more tricky part, right? Cons employee-temp, and then the first of employee-ls. All right, so this, right? This, we're going to need to take the role here, right? And then, right, because that's the role, so that gets the role of everyone. So in this case, Ava, it's going to be manager. In case of Jack, it's going to be Anna. Jack, in case of Jack, it's going to be manager. In case of Anna, it's going to be senior. In case of Bob, it's going to be junior. In case of Jess, it's going to be intern. Right, so that gets the role, and we want to compare it with the role that we're given, right? So string equal role. All right, so I'm going to run this. And filter role takes in 2 arguments. We only found 1. Right, I have to pass in the role here, right, that comes along for the ride. All right, so you're going to see this is wrong, but it gets us kind of there, right? You see that list true, true, right? So this true, true refers to how this list, right, Ava and Jack, they're both managers, right? So true, true, and then false, false, false. True, true, false, false, false. right? It's not quite what we want, right? Because we only want Ava and Jack because they're both managers, right? Only these two guys. Everyone else get out because you guys aren't managers, right? We only want to filter in the managers here, right? So it kind of gets us there, but at the same time, not really, right? So what we need to do actually is we need to wrap this, right, around an if, right? Because this, right, this produces a Boolean. We want it to produce the employees itself, right? So like so. And we want to move this, right? Because sometimes, you know, put this out here. Sometimes people are managers and sometimes they're not, right? So we have to selectively include people in the output list, right? Because that's what the purpose statement says. Produces only the set of employees of the given role, right? So we need to wrap this around an if we rolled earlier, right? Comparing the given role with the employee role, right? The given role, the employee role. So if it is that, then do something, right? This is the true branch, this is the false branch. So let's fill those out, right? If the employee does match the given role that we want to include it in the list, right? So this is including it in the list, right? I'm gonna hit Control I to reindent that. Otherwise, right, this is the false part, the false branch, right? Otherwise, if it's not the given role, right, then we just want to call filter role with the rest of the list, right? Not causing it on, right? This is, I'm gonna space this into one line, right? Because that way, it's easier to see, right? If has three parts, true branch, false branch, right? So it's easier to see that in that sort of way, right? So if the given employee is the given role, then we want to cons the employee onto the list, onto the rest of the list, right? In case there are two employees or more. Otherwise, right, don't include it in the list, right? We're not doing cons in this branch, right? Keep going and look through the rest of the list and see if there are any other managers, right? In this case, right, there's only two managers, but you're welcome to write another test that has a manager, another employee that's a manager, way at the end here to see if it works. But in this case, I know this should work, and all 7 tests do pass for filter role, right? Now let's move on to problem D. All right, so problem D says design a function count-roles that consumes a list of employees in a role and produces the count of employees in that role, all right? So here's the signature, count-roles consumes a list of employees in a role, and this time it produces a number, not a list of employees. So it should be pretty similar to this, right? Anywho, pause video, over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So that's the signature done. Let's do the purpose statement here. Produces the count of employees in the given role. All right, so signature, purpose, let's stub this out. So define count roles. Consumes a list of employees, right? So we're gonna name this parameter empll-ls and then a role, and then produces a number. So we'll just use 0 as a dummy value to run again some tests here. So check expect count roles. So what happens if no employees are in our company, right? And we want to find out how many managers there are, right? Manager, right? Well, 0 because there are no employees in here, right? So let's do some more complicated tests with all the other employees. I'm gonna copy and paste this down here, right? Because I don't want to keep scrolling up and down for it, all right? Okay, so let's do another test here with everyone else. Count roles, everyone, right? So here's everyone, Ava, Jack, Anna, Bob, and Jess. All right, so let's say we want to count up the amount of managers, right? In this list of everyone, right? So how many people in here are managers? 2 people, right? Ava and Jack, right? So that should produce 2, right? Let's do another test here, but let's do something more interesting, right? Let's do something like junior, right? So we want to find out all the juniors in this list, right? In this case, it's, you know, just 1 because Bob is the only junior here. So this should produce 1, right? And let's do a test, expect here, count roles, everyone, not everyone. Let's do this list, right? The 0 interns list, right? So Jack, Anna, and Bob. So here is Jack, he is a manager, Anna is a senior, and Bob is a junior, right? So no interns. There are no interns in this list. 0 interns. That's the name of the list here. That's defined all the way above. All right, and we want to find out how many interns there are. Well, there's 0, right? So like so. So that's a good amount of tests here, right? So let's just run it against our stub here. and we just get differ, so that's fine, right? These two tests pass because we just spit out 0 here in our stub. It's just mismatches, so it's fine. You can comment it out. And we're going to find something that consumes a list of employees. So you look for the template that has that. And if we scroll up all the way up here, we did that for problem A, so that should help us nicely. All right. Rename this to count roles, right? And then list of employee, and then a role. So this consumes 2 arguments. All right. And this time, right? Yeah, this time it produces a number. All right. Anywho, pause the video. Hopefully this should be all the mental scaffolding needed for count-roles. I'm going to go with spoilers in 3, 2, and 1. All right. I'm assuming that you guys took a good swing at it. So now let's go over it together. So in this empty case, right, what happens if we're given an empty list with no employees? Well, we just produce 0. So that test, an example, gives us this answer here. Otherwise, what do we do, right? Well, we're going to have to produce a number depending on if the employee is the given role, right? So we're going to need an if here, right? So if the employee is the given role, so we'll just copy this because we're going to need this, right? Employee-temp. We're going to get the employee's role out, and we're going to compare it, right, to the given role, right, that we're given into this function. Right, if it is the given role, then we want to add 1, right, because we want to count up the number of employees in this role, right? Reduces the count of employees in the given role. So this is what happens if it does match the given role, right? So we're going to add 1 to the result of looking through the rest of the list, right? Because there might be other employees with the given role. So we have to pass in role here, right? Because count roles is a 2-argument function that comes along with the ride. And likewise, in the other case, if it's not the given role, right, we don't want to add anything, right? So you see here for manager, right, we only want to add 1 every time there's a manager. For these others, we don't want to add anything, right? So this is that other case, right? We just don't do anything. We just keep looking through the rest of the list. And likewise, this count role takes in 2 arguments, right? So we need to pass in the given role here, like so. And that should produce the result that we want, passing all the tests. Likewise, right, you might realize that this is what filter role does, right? We could just count up, we can use filter roles to implement this function, right? So we can refactor this to, right, assuming that you did problem C first, we can just use define count roles, emp-ls role to be a call to filter roles, right? So filter role, yes, and then the empl list, right? We still have that. ls, and then the role itself, right? So this will produce a list, right? We know that, right? A 0, this list differs from 0, and this list of employee differs from 1. But you can see the amount is the same, so all we gotta do is pass this to the length function. And that also is another way of implementing this, right? Using, more and more function composition. But you have to be aware of, that you can use the length function. But either way is valid, right? You can either write it this way or this way. But, I prefer you guys write it this way because it gets you guys more used to, taking apart the fields, right, of a list of structures, right? Because, this is what this section 18 is about. We're doing a list of structures, and you got to get used to taking it apart and using them in the list, right? Anywho, try to submit this into hand it in to the 18.0 series, and check your score, check the grader side test to make sure you pass those. And yeah, anywho, that's about it for this video, and I'll catch you in the next one.